My name is Ruben Vruggink, and I want to present my capstone work, Advancing Regional Sediment Management in Southern California. It's been an interdisciplinary evaluation of sediment reuse at Mugu Submarine Canyon with the goal to sustain the Zuma Littoral Cells beaches. And my research is done with two capstone partners, Royal House Cunning, DHV, and Beacon. I was really fortunate to work with both. So a little bit about me, where I grew up, what is part of my personal story. I was born and raised in the Netherlands, where half of our country is below sea level. So the ocean has definitely played a really big role in my life and also the history of our country. Definitely a lot of history lessons with a lot of big natural hazards and a lot of coastal flooding. So it played a really big role in my life. And not only all the negative things, but a lot of the positive things. I have a really lot of fond memories being on the coast in the sand, researching what kind of organisms are in the sand. A lot of fond memories with family and friends there. So it it made a really big part of my childhood, but it also I got to see and experience a lot of coastal storms as a kid in places where I grew up and were really dear to me and people that I cared about. So seeing those places damaged and flooded by coastal storms really triggered or got me curious, made curiosity going for why those things are happening and what our role as humans should be with the coast as well as the ocean. And it's also good to mention that the Netherlands is a place where there's a lot of really great coastal projects, from hard structures to a lot of nature-based solutions. We are definitely a place where we've been working with the ocean for over 1,000 years. So it played a pivotal role in my upbringing as a kid. So I wanted to take a step away from my upbringing, and I'd like to start with a little short exercise during this call. If you feel comfortable, gently close your eyes or soften your gaze in front of you. Now I want you to imagine the state of California. What do you see? Maybe it's the coastline, rugged cliffs, golden beaches, waterfalls cascading onto the sand. Picture yourself there, barefoot, standing on this beach. Feel the sand between your toes, scoop some up, let it slip through your fingers. Take in the beauty around you. Now imagine that same coastline, but without any sand. No beach to walk on, no place to gather with friends and family, just bare rock and gravel. Go ahead and open your eyes. I want to This is definitely one of the futures that might happen to the state of California, as up to 70% of California's beaches could disappear by the end of the century. And I wanted to begin this way to highlight just how central beaches are to California's identity, not just aesthetically, but also socially and economically. Beaches are where we connect with nature, with each other. They're vital for recreation, tourism, and the livelihoods of many Californians. And yet, in many places, they're disappearing. So I really wanted to focus my 2 years of my capstone and my time at UC Santa Cruz to look into solutions, how we can maintain those beaches. And I did that in the region of the Zuma Littoral Cell in Southern California, just west of Los Angeles, where it's a region where a lot of the beaches are slowly disappearing, and we'll dive into the reason for that in a bit. I wanted to take Broad Beach as an example right here, located. So if we're comparing Broad Beach in 1972 compared to 2024, two aerial photographs. You see the road here in both and the little triangle of vegetation as well as a reference. You see in 2070, there's a lot of houses with beautiful dune area as well as a broad beach in front of it. That's because of the name. That's why the name came from. And if we compare that to now, 2024, a lot of the beach sand is missing, as well as there is a revetment and a rock revetment placed there to make sure that the property and the houses don't flood or don't disappear in the ocean. So what is happening here, and why is the beach disappearing? That's the question. This is another graph showing the strong decrease of beach width in the same location, Broad Beach, between 1970 and 2010, really showing that the beach has almost disappeared. So to really figure out what is happening, I wanted to give a one-on-one of sediment transport to the call here, and we should start where all our sand grains start, and that is in the hills and the mountains. They get transported down by the streams and gravity, in our watershed or the sand shed, make it down. Some of it gets trapped behind dams, but most of it makes it down to the California coast and forms beaches right in front of the river inlets. This sand is then transported by waves and winds, following the direction of the wind. So in this diagram, the wind is coming from the left and transporting sediment to the right. And what is really important to point out here is that a lot of the sand in California is lost into submarine canyons, where it is lost into the deep, and we can't use it for our beaches anymore. So you can imagine with all that sand going down here in the canyon, the beaches on the right side of it are not getting sand like they used to. So that was my research on, and that's what I really wanted to focus on, to look if we can reduce the sand loss into the canyons, as it is a very valuable resource in the state of California. So I wanted to make an overview of where our sand is coming from and where we're losing it in this region. A lot of our sediment comes from Santa Clara River in Southern California, goes down, gets transported down coast, and then we lose over 1 million cubic yards of sediment into the Mugu Submarine Canyon every year. What is the biggest sediment sink in California? And you can imagine with all the sediment being lost into the Submarine Canyon, the area right on the right side of it isn't getting as much sand as possibly could. That's what I wanted to focus on, this region. So the Zuma littoral cell is a 20-mile stretch of coastline where a lot of the sediment is moving down coast and is dropped into this canyon. In 1950, it was estimated that around 20% of that million cubic yards was bypassing the canyon naturally, but now it is estimated that we lose over 100% of the sediment into the submarine canyon. So what my research was about is looking into if we can go back to the natural ways of making sure those beaches are getting the sand, and reducing the sediment that goes into the canyon by 20%, taking that 20% and putting it over the beaches in this region to make sure they maintain their beach width. So a little bit about this canyon and what is in front of it. So there is a naval station right in front of it, and the canyon is right here. And this is the path the sand travels by wind coming from the left and then making it down into the canyon head. You can imagine that if or when 50 or 70 years ago, this canyon wasn't as close at the coast, that sand would actually make it around the canyon head and would provide sand to the region. But this is not happening as all sediment is now lost into the canyon. So that's why I wanted to focus on this area. So the problem here is coastal erosion, sea level rise, and a decrease in sediment input will threaten beaches in California and beyond. Submarine canyons, when present, can be sediment sinks for such beaches. So the goal is here to improve erosion reduction on beaches located down coast from a submarine canyon. And to really tackle this goal, it was really necessary to be providing policymakers with accessible regional sediment management strategies, as this will enhance the long-term preservation of California's beaches. And I used a three-pronged approach for this. So the first step was really to understand the historical sediment dynamics in the region, and that's all the information we just went over earlier in this presentation. The second part was to be projecting the future, and we used a shoreline model for this, looking into how our beaches are gonna be in certain years if nothing is done, as well as if our regional sediment management strategy is implemented. And the third one, and probably the most important one, is to evaluate the feasibility, not only economically, but also politically and socially. So what are my big results from my capstone research? One of them is definitely that it is estimated that the yearly visitor loss will be around 1 million people by 2080, meaning that if nothing is done, nothing is implemented, by 2080, there will be 1 million people a year not being able to go to those beaches anymore because they're not there anymore. They got reduced in size so much there's no space. Another really big result is that by 2080, the total annual loss is going to be around $70 million by 2080. So let's look into our adaptation strategy here and if that is actually helping the solution at all. It is concluded that reusing sediment otherwise lost into the submarine canyon can maintain beach width in Zuma littoral cell until 2080. That's a great conclusion, but now we still have to figure out if it is going to be cost effectively or not. So looking at this graph, the cost benefit ratio, meaning that if the cost benefit ratio is above 1, meaning that the costs are equal to the benefit, if it's higher than 1, it's going to be cost effective. So we took different scenarios here, depending on the cost of how much it's going to cost to move the sand. And even in our highest cost scenario, it was going to be an economically viable solution, or is. So this is all really great research, and I had a lot of enjoyment finding these research results. But the most important thing was to bring those results and the most up-to-date research to the government entities, the stakeholders, and policymakers that actually are going to do something with it. And I made sure that, or together with Beacon during the Sediment Summit of 2025. I made sure that my research, as well as all the researchers that have been researching the Zuma littoral cell, got to have a place to be presenting this, as Beacon every year organizes a sediment summit, but this year it was all on the topic of the Zuma littoral cell. So we got to research or present all our research and get a lot of really great feedback from policymakers and government entities. And then after that, we got to have a good field trip at the Navy base to be showing them on the ground how it is looking there and where this canyon head is located, to give them a better understanding of what is happening here. So what is the dream here of the Capstone? It is really to scale this approach to other canyon interrupted littoral cells in California and beyond. Also looking into a interdisciplinary approach for regional sediment management. And this will help to reduce erosion, preserve beach access, and enhance coastal resilience. And I'm going to conclude my capstone work there and use a couple minutes to also share with you my personal professional development, as I think it played a really pivotal role in my last 2 years of education here at UC Santa Cruz. I visited a couple really great conferences, all of part of ASBPA, which stands for American Shore and Beach Preservation Association. The first conference was in Ventura, California, what was really state focused in 2023. The second one was a national conference, a scientific based national conference in Texas, Galveston, where we really focus on a lot of scientific research around the whole United States, not only California based. And I got to see how other coastal states were dealing with their problems. Then earlier this year, I got to visit the Coastal Summit in Washington, D.C., which was more of a policy and governance and funding conference, and different states got to do hill visits representing their state and having meetings with senators and their staff to talk about coastal issues and really bring it at the front door of Washington, D.C. And then lastly, what I'm really proud of is that I started initiative an initiative UC Santa Cruz student chapter of ASBPA, meaning we'll have a chapter here at the university where students and young professionals can come together and share their passion for coastal problems and coastal resilience to find solutions for them, as well as a networking opportunity to share with others student chapters around the United States and see what other students and young professionals are working on and share ideas. So what are my next steps and career pathways? I'll be joining Integral Consulting as a coastal scientist after graduation. I'll be contributing to multiple projects, one of them being the coastal hazard erosion control and mission readiness at the naval base that we earlier talked about. This will make sure also that I'll stay in close contact with key stakeholders for this capstone and see and can oversee some of the next steps and still be involved in that. So before I want to dive into any of the questions and remarks, I really want to take some time to thank the people that without their help, this project would have not been as great as it got to. So thank you for all the support and wisdom, starting with Dr. Gary Griggs, who without him, I wouldn't have been here at UC Santa Cruz. In my first 3 months as a undergrad, as an exchange student, I got here. I have a lot of really great talks with Gary, as well as like a lot of great readings from him. Really sparked my curiosity to coastal sciences. So thank you. Dr. Borja Ruggiero, who really gave a lot of technical advice and really made sure and helped me figure out the capstone and different deliverables and really get it all on paper and plan it out, and gave me a lot of really great advice on career steps and etc. I want to take some time to thank Lars de Ruijg, Dirk-Jan Dauma, and the broader Royals Coding DHV Climate Resilience team in the Netherlands for the opportunity to learn a lot from their international projects, as well as learn a lot from the coastal about coastal economics. I want some time to thank Mark at Beacon for co-organizing a really great Sediment Summit, what I think was a really big success, and I'll be looking forward to being a part of the Sediment Summit for the years to come. Then the CSP program, and in specific NSERA for all the support throughout the 2 years and before that, and my 2025 cohort. I thank you guys for giving a lot of feedback and listening endlessly to my presentations about sediment and sand. So thank you. And then lastly, of course, the Center for Coastal Climate Resilience, as I was fortunate enough to be a fellow with them, and they really made it possible for me to follow my passion and interest for the last 2 years in the coastal resilience realm. So thank you all for listening, and I'll answer any questions.